Hi, this instructional video is a continuation on exponents. This particular one is about two different division properties. One is called the quotient of powers, and one is called power of a quotient. Kind of like what we talked about multiplication properties. Give you a quick little information about this one. When we talk about quotient of powers, here's a number with an exponent. Here's a number of an exponent. So there's a power, and this is a quotient of two powers. And here's how it works. Well, here's the way I recommend it. You ask yourself, hey, they have the same base. Which one has the bigger exponent? In this case, the 8 is the bigger one. Then what happens is you take the smaller exponent and go to the bigger one and subtract. It's like the younger person goes to the older person to ask for advice. The smaller one goes to the bigger one. Okay? Of course, in real life, it's not always like that, but... So in this case, you get 1 over x to the third power. Likewise, if this was reversed and the bigger exponent was on top, once again, the smaller exponent goes to the bigger one. And then you subtract the exponents. So for this particular example, you get x to the third. Okay? So now, seeing that example, and I'll put that right over here, you try number 1, 2, and 3. All right, so you said, same basis, 7 is the bigger one, so the smaller one goes to the bigger one, leaving you with just the one on top, because there's nothing remaining. And you end up with negative 2 to the 7 minus 5, which in turn becomes 1 over negative 2 to the second power. And that's a good answer. Unless you wanted to evaluate that, which you could, then if you did, you'll say 1 over 4. Which is even a better answer. And this one? Yeah, this one was a little tricky one. You have to combine the two powers. Okay? Remember product of powers? So you're supposed to add the exponents first because the bases are the same. So x to the 8th over x to the 5th. Now you go, oh, there's a smaller exponent. Go to the bigger one. And then you subtract the exponents. So you end up with x to the third power. Whoops, not 8, x. Here, x to the third power. And finally, yeah, you learned this in elementary school. When you have a fraction, when you're multiplying or adding or subtracting, try to match it up by making this over 1. So in this case, when you multiply across, you get x to the 4th over x to the second power. Again, the smaller exponent goes to the bigger exponent and subtract, so you end up with x to the second power. There you go. Then how about the second type of division property? Now when we talk about power of a quotient, here's a quotient. Here's a quotient. And if we give it a power, and the rule is this, each of those term, or each of those factors, gets the exponent. So you end up with x to the third and y to the third. And of course, you remember the rules of exponent. If this was a negative exponent, that means this is in the wrong place, right? And this is also in the wrong place. And this is supposed to go down, while this goes up. So it actually becomes y to the third over x to the third. So in fact, if you have a negative exponent of a quotient, you could just take the reciprocal or flip the whole thing. You try to simplify these three. All right. So you said, all right, 3 goes to the 2 and 3 goes to the 7. So you end up with 2 to the third and 7 to the third. If you wanted to, you could evaluate. 2 to the third is 8, of course. 7 to the third is 343. I cheated. I used the calculator. Okay? And this one? Yeah. You could just switch the places on this one. Say x to the third. Whereas the negative 3 now becomes a positive 3. Now apply the negative 3, the 3 to each of the terms. We get x to the third and 3 to the third. And you should try to simplify that one so it becomes x to the third over 27. And finally, negative x to the fourth. And 5 to the fourth. Oops. And we'll let somebody with the calculator figure this one out. But there it is. Now that you know about rules of exponent, particularly about multiplication properties and division properties of exponent, we could actually solve these three crazy looking expressions. So why don't you try it? Alright, here's what I recommend. Let's go ahead and use the multiplication properties of exponent. What that means is just multiply across. All the numerators on number 1, for example. Let's say the coefficient 4 and 5. 4 times 5 is 20. X to the third, x to the first, same basis. You add their exponent, so you get x to the fourth. Y to the third, y squared, add the exponents, y to the fifth. Over the bottom now, the coefficients 2 and 2, they multiply to become 4. X to the first, and, oh, no more x here, so it's just x. And y to the first, you add their exponent to become y to the second. Of course, some teachers will show you to cross-cancel, simplify diagonally and up and down. I just show this to show consistency. So now that you combine all the terms, we could simplify. You know 20 divided by 4, they reduce to become 5. Which one is smaller? X to the fourth or x to the first? X to the first is smaller, so you go up and subtract with the 4, so it becomes x to the third. Y to the second is smaller than y to the fifth, so the 2 goes up, subtract from the 5, becomes y to the third. This way is a lot cleaner, and you could show step by step and use the both multiplication property of exponents and the division properties of exponents after. Now you try number 2 and 3. So you said 16 times negative 2. The coefficients, they become negative 32. X to the third and x to the first, add up the exponents to become x to the fourth, y to the first, and this y to the first is y to the second. Over negative 4 times the invisible factor 1, or just negative 4. X to the first, add up the exponent to become x to the second, and y to the third, and no more y's, so it's just y to the third. Now let's apply the division properties of the exponent. Let's simplify negative 32 and negative 4. That becomes positive 8. Negative becomes positive. 32 divided by 4 is 8. X squared is smaller than x4, so it goes upstairs to subtract the x squared. X to the second power. This time, y squared is smaller than y to the third, so it comes down. And subtract from y to the third, so you get y to the first, or simply y. And that becomes the answer for number 2. And finally, number 3. I recommend it using the multiplication property of the exponents. So 36 times the invisible factor 1, so you get 36. A to the 8, a to the first. Add up the exponents to become a to the ninth. B squared becomes b to the 2 plus 2 is 4. Over a to the and b to the and 6 times the invisible factor 1 is 6. That was not too exciting, but we're getting the job done. Now 36 divided by 6 is simply 6. A to the first is smaller than a to the 9, so we go up and subtract 9 minus 1 is a to the 8. B to the 1 is smaller, so it goes up. B to the 4 minus 1 is b to the 3. And there you have it, using all the properties of exponent.